Continuing on in the Desmos activity here, this video will cover slides 11 through 24. So here it says write a polynomial function that has the following features. Okay, so it says the right end behavior is negative and the left end behavior is positive. So those are going in opposite directions. So what I know is that this has to be an odd polynomial, odd degree polynomial, so 3. Okay, but right now my right end behavior is going up, so I need to flip that. So as we've learned in the past, how do we flip a graph or reflect it? We just make the leading coefficient negative. So here I have a polynomial, it's a third degree polynomial, right, where the right end behavior is negative infinity and the left end behavior is positive infinity. And so in order to do that, I had to make my leading coefficient negative to make my right end behavior negative. Because as you plug in a really big number, right, in order to make sure that's negative, right, you have to multiply that number by a negative. And that's the only way to make that negative. And again, we recognize that odd, okay, gives us the different end behaviors. And now we want to go left end behaviors, positive, right end behaviors. So now they're the same. Okay, so this is just going to be an even polynomial. So we could just go with a quadratic here. Right, and both end behaviors are positive because my leading coefficient is positive. Again, if I made that negative, now my both end behaviors are negative infinity. I want positive infinity. Okay, so I'm going to have a positive leading coefficient. Okay, why is the left side going up? If again x is getting really small, because when you square negative, right, it makes it positive again. So anytime you do any even power, okay, right, any number to an even power will always be positive. Because negative times negative is always positive. All right, comparing even and odd degree polynomials. Okay, so here it says click on the circle in front of the function and make the function appear and disappear. Right, so click on it, goes away. Compare the fourth degree polynomials. Focus on the leading coefficient, okay, on what the leading coefficient does to the right end behavior. So here, okay, I kind of talked about this already, but we want to see it. So comparing these two, right, the red graph has a positive leading coefficient. Okay, focus on what it does to the right end behavior. It is going up. Okay, focus now on the blue one where the leading coefficient is negative, it's going down. So again, this is even, but both of our end behaviors are going in the same direction. All right, they're both either going to be both positive or both negative. What's going to make them both positive is when your leading coefficient is positive. Because no matter what, even is going to make that number positive and then keeping it positive. It doesn't matter what's going on over here. This fourth power is going to be so much bigger than the other ones. Doesn't matter what those signs are. All right, and then how do I make sure it's negative? Well, just throw negative in front, because now when you raise it to the fourth power, it's positive, but then you multiply it by a negative, it changes both to negatives. All right, now we look at a fifth degree. Look at this fifth degree, right? It has 1, 2, 3, 4, 5 x-intercepts, 1, 2, 3, 4 turns, and behaviors are going in opposite directions. Everything that we've just noticed, right? Look, it's positive. What's the right end behavior doing? It's going up. Again, because when I plug in a big number for x, right, it's going to stay positive. Anything to an odd number is going to keep its sign. Okay, so because positive times a negative is a negative, all right, but then so it keeps the sign. All right, and so that fifth turn, that odd one turns it back to a negative if it was a negative, but if it was a positive anyways, positive times positive is always positive. So if I plug in a big positive number, okay, it's going to stay positive. If I plug in a big negative on my left side, plug in negative 10, right, it's going to be negative number. All right, and again, doesn't matter what's going on, the fifth power makes it grow that much faster or more than the other ones, so it's going to control the sign. Okay, if I throw in the negative leading coefficient, it does exactly what I anticipated. It's going to reflect. So the right end behavior is flipped to going down. And again, that makes sense now because now, again, when I plug in a really big number, right, it becomes really big, but then I multiply it by negative and it flips it, makes it a really big negative number. Okay, so what we're learning here on this slide is that the leading coefficient controls the right end behavior. All right, and then the odd or the even part is going to control the left. So remember, if it's odd, it's opposite. So whatever the right's doing, the left end behavior is doing the opposite when it's an odd degree. But when it's an even degree, they're always doing, the end behaviors are always doing the same. All right, so here we want to write a cubic function in factored form. All right, and so it says write a function by picking any integers for a, p, q, and r. Type it here in line 2. A cannot be 0, okay, because that makes the whole thing 0. And p, q, and r must be all different integers. All right, so if I go h of x equals, let's make a 1, and we'll go x minus 2, x plus 1, and x minus. All right, so there's my graph. All right, and so we're gonna study this here in a little bit, but right, it looks like it's gonna be an odd degree because my end behaviors are going in opposite directions. I have 3 x-intercepts, so this looks like it's gonna be a third degree polynomial, which it is. If I FOIL this out, I would get x times x times x is x cubed. So this is definitely a third degree polynomial. Okay, so here's that same graph. Okay, what are the zeros of the function? Well, the zeros are -1, 2, and 4. Okay. Zeros are when x equals -1, 2, and 4. What is the relationship between the zeros and the equation of your function? So again, if I come back to my equation, look at my factors, x minus 2, x plus 1, x minus 4. Okay, my zeros are 4, 2, and -1. So look how what those do to my factors. They make each of my factors equal to 0. So we know that the zeros are related to the factors. And again, they are what make each factor equal to 0, right? -1 makes x plus 1, 0. 2 makes x minus 2, 0. And 4 makes x minus 4, 0. So what is the relationship between the zeros and the equation of your function? A, make each factor equal to 0. And that's probably why we call them zeros. Right? Another word for x-intercepts. Another word is roots. All right, so pay attention for those words. They all mean the same. Okay. It says write a polynomial of this form. Okay, so now the only difference here is that there's a squared on there. So again, so if I go ahead and let's make this one negative. Right, let's go x plus 2 squared, x minus 1, and x plus 1. And we're going to want to copy and paste that into the next one. All right, so I'm anticipating that there's going to be an x-intercept at -1, at +1, and at -2. All right, what degree is this? Is going to make what's my end behavior is doing. So let's take a look at this graph. All right, so let's plug it in. All right, my end behaviors are both going down, so they're the same. So this must be an even degree. Right? I have 1, 2, 3 x-intercepts, 3 turns. Okay, this is going to be 3 turns, means this is going to be one more than that, 4th degree polynomial. Where am I getting 4 from? Right? This has an exponent of 2, 1, and 1. So if I add those up, it's 4. Right? So if I were to FOIL that out or distribute that out, right, it'd be x squared times x is x cubed times x is x to the 4th. So this is a 4th degree polynomial. Leading coefficient's negative, so it does make sense that my end behaviors are going down. All right, so here it says pay special attention to the location of the zeros and the end behavior, okay? Especially the 0 of the factor that is squared. So what is going on at -2? Right? It hits the x-axis, but then it bounces right off. It turns. It's an extrema point. It's our maximum. It doesn't go through it. It hits it and then changes direction. All right, so that's kind of unique, and that's unique that it's squared. All the other ones go straight through it. All right. So what is the degree of this polynomial? So we just talked about this. This is a fourth degree. And the end behaviors are the same. There's 3 terms, right? And if you FOILed it out, multiplied it out, you would have got x to the 4th. Are the end behaviors behaving as you anticipated? Yes, okay? They are the same, okay? So they are behaving the way they should. All right? 4th degree is even. Remember, even should be the same. All right, so let's look at more double roots to see if that's always true. So this one right here has no double roots. All right, 2 times x minus 1 times x. There's no double roots here, but the factors, right, the x-intercepts are at 1, at 3, and at 4 like they should because they make each factor 0. Right, they go straight through. All right, now if I look at this one, okay, same exact factors, but the x minus 1 is squared. What is happening at the x-intercept of 1 right now? Again, just like on the previous one, it touches it, and it changes direction, and it bounces back up, bounces off. There's an extrema point. There's a turn right at 1, the factor that was squared. Okay, let's look at this one. Now the x minus 3 is squared. So I'm going to guess that it's going to bounce at 3. And I come over and I look, and yes, it does bounce at 3. Goes straight through 1, goes straight through 4, but it bounces, okay, at 3. Right, my end behaviors are the same. Leading coefficient's negative, so it goes down. All right, here we got leading coefficient going down, so negative. But here we have 2, okay, factors that are squared. So this is actually going to be a 5th degree. So my end behavior should be opposite. Okay, I'm thinking it's going to bounce at 1 and bounce at 4. So I come over and I take a look. Does bounce at 1, does bounce at 4. 3 does not have that, so it just goes right through 3. Leading coefficient's negative, right end behavior is down. It's odd, it's 5th degree, so the left end behavior is opposite. Right? And then the last one, I've got square, square, square. So I think it's going to bounce on all of them. All right, it's even 6th degree, so both end behaviors should be going up. Okay? Both end behaviors are going up, bounce, bounce, bounce. So that's exactly what happens there. All right, so now we're going to examine some triple roots. So same thing. Okay, I'm going to type in an equation. Okay, let's see what happens when I cube a factor. All right, let's just make a1, go x minus 1 cubed. Okay, and then oops, so x plus 2 and x plus, copy that, paste that in. All right, so now we're looking at our graph. We have x-intercepts at -2, at -1, and at +1. Okay, look at the difference. What's going on at 1? Right, at -2, it's going straight through at -1. Okay, then here it looks like it almost gets flat before it goes through. All right, so that's pretty unique. We call this a point of inflection. Okay, it's changing concavity. It's something you'll learn in future classes, but right now we just need to know that's called a point of inflection, when it gets really flat before it goes through. All right, so let's see if that's always true for a third, when a factor is raised to the 3rd power or cubed. All right, so what is this degree? All right, so it's odd, definitely, because the end behaviors are going opposite directions. Okay, I have 3 x-intercepts, all right, but this one was unique, right? I have 2 turns, so is this a 3rd degree? 3 x-intercepts, okay, 1, 2 turns. Let's go back and look. All right, so here I have 3, 1, and 1. So just if I multiply that out, x cubed times x is x to the 4th, x to the 4th, okay, times x is x to the 5th. This is a 5th degree. And again, I know it only has 3 x-intercepts and 2 turns, so it might be 3, but this x-intercept is unique. It has a point of inflection happens. So we call it a triple root. Okay, so our degree is a 5th degree polynomial. Okay, and yes, the end behaviors are opposite. It's odd and the end behaviors are opposite. Okay, yes, it is odd and the end behaviors are opposite. All right, so if we study this, all right, again, the first one, there's no triple roots. Everything just goes through smooth, straight through it. All right, now I have put a triple root. I've cubed on the x minus 1. So I'm anticipating something going to happen differently at 1. So if I come and look at 1, yes, something different, right? It gets flat, where the other ones, right, it looks different. Again, the vocabulary word is point of inflection. All right, now we look here. I think that point of inflection is going to happen at 3, and it does. All right. Now, if I look at this next one, I see a squared and a 3. So I'm thinking it's going to bounce at 1 and have a point of inflection at 4. Let's see. All right, it bounces at 1, right? It hits it and changes direction. That's what I mean by bounce. Okay, and then at 4, it has a point of inflection. It gets flat. Okay, look, so it's a even degree. They're both end behaviors are going up. What degree is it exactly? Again, we get that by adding up the exponents here. 2, 1, 3. That adds up to 6. This is a 6th degree polynomial. On this last one, I got cubed, and squared. So I'm thinking point of inflection at 1, point of inflection at 3. I'm thinking it's squared at here, so it bounces on 4. All right, so my degree is 8. All right, so it's even, leading coefficient's negative. I think both end behaviors will be going down, right? Which they are. Point of inflection at 1, point of inflection at 3, and a bounce at 4. So we are pretty sure we know what's happening every time it's cubed. Okay, and this is actually true for all odd exponents. It will have a point of inflection. And we know when it's even, okay, squared, and this is true for all even powers, is that it will bounce. It will have an extrema point.